Situated. We have a lot to do. This is one period, and we got a couple of siblings having more seats. Oh, it was nice. And this morning, I'm walking down one in science. Was that sophomores? Yeah. Okay. So the lights aren't on. One light's on. I'm in a rush to get to the workout. Well, I ran into the stupid spider web, and it was like sticking to me. Oh, it's gross. Oh, in the sophomore hallway. I mean, part of it's knocked down because I knocked it down. I don't know if it's still knocked down. Did you? Did you see that? Okay. As you have noticed, I omitted a problem in the homework. Yes. So in the 2.4 homework, the 2.4 homework, number 5 has no equations. So you need to add on the 2.4 homework, you need to add this is number 5, x cubed plus 3x squared minus 5x minus 4. So write that down. And because I feel badly that some of you tried it, I couldn't do it because it wasn't there, and I delayed your getting the work done, even though it's not due tomorrow, right? It's due tomorrow. But I'm going to go ahead and do this problem so it will be done. So those of you that did everything else will have it done. All right, so prove that 2 either is or isn't an upper bound. All right, so what do we do? Proving something is or isn't an upper bound. Synthetic division. So we divide by 2. And if I didn't make any arithmetic mistakes, is 2 an upper bound? Yeah. Yes, because everything came out positive. Or because zeros are allowed, you might say everything came out not negative. Right? Zeros are allowed. Find the roots exactly. Now, this is a helpful piece of information because your PRRs, this does not factor by grouping, so your PRRs are factors of 4 over factors of 1. You're not going to pick anything. Well, the only positive option here would be 1, right? Because we know it's not 2 and it can't be 4. So that really narrows down our options. We're looking at 1, negative 4, negative 2, or negative 1. So I don't know. What do you want to try? This is 2 is an upper bound. 2 is an upper bound. That means no answer bigger than 2 can work. And I already know 2 doesn't work. Right? Okay. So what is going to work? I can see 1 isn't going to work. Negative 2? Let's try negative 2. Quit yawning. This is the most fun you have. Oh, that's not going to work. Nope. How about negative 4? I think 4 works. Negative 4 works. Did somebody say 1 works? 1 doesn't work. Doesn't it? I don't think so. It doesn't? Oh, it doesn't. Well, think -4 works.
Yeah.
So one, it says find all the solutions. No, it says, yeah, it says find the roots exactly. So, one of my roots is -4. The other roots are gonna come from x squared minus x minus 1, which is a quadratic that does not factor. So x equals -b plus or minus the square root of the squared minus 4ac all over 2a. So it says find the roots exactly. I think here they are. Now, could you find these roots on your calculator by graphing and doing finding the zeros? You could, but what's wrong with that? They wouldn't be exact, right? They're going to be decimals. So if you want exact roots, you're going to have to do it by hand. 1 plus root 5 over 2 is some decimal, 1 minus root 5 over 2 is some decimal. But those would be rounded off because root 5 is an irrational number. All right, so that one's done. Sorry about that. What?
On the 2B, I only got 1 rational root. Do you want us to get the other one from our calculator or no?
What did the directions say?
It says find all real zeros.
Find all the real zeros?
So put their
Find all the real zeros then, yep. Find them all.
I don't think that's right.
So are you talking about 2B?
Yeah.
Okay, when you found one, you divided it out, you were left with a cubic.
Yeah.
Did you try the PRRs for that cubic? That's what you should do. Then if none of them work, so whatever the PRRs are for that new cubic equation, if none of them work, they go to the calculator. Okay? But if one of them works, you'll divide it out, get a quadratic, and you can solve it from there. Okay?
Wait, on that question, when you're trying to find the PRRs for the cubic that like you get, should you use the
That
equation
yep.
in the cubic?
Yep. Yep, that's the equation you're solving. All right, now, we're gonna have a quiz tomorrow. So I went back through my pile of stuff. I'm not telling you this is a comprehensive review. Would you like one? She said no. I'm sure if I asked Lucy that, she'd say no too. So I'm not asking. You don't want her to know? All right, so here we go. You guys probably don't remember, Mr. Knoll actually used to be our teacher of this course, and he left. And when he left all of his stuff. Well, not all of his stuff, but a lot of stuff. So this is his, actually. This is some stuff Mr. Knoll had put together. I kind of cut it up and glued it together to make a little bit of a view sheet. So here we go. Number 1, sketch the polynomial. Well, this is beautiful because it is factored for us. So what does that tell me?
Zeros.
I have zeros at 1, which I'm going to label. Guys, we got to get in the habit of labeling our intercepts, all of them. -2 and -4. What is the degree of this polynomial? In other words, how many x's do we have? X to the what? 4. A 4th degree polynomial starts up and ends up. Since there's no negative coefficient in this problem, it is going to start up. And it's gonna come down and it's gonna hit this point, and what's it gonna do when it hits it? Goes through it. Goes down, comes around, connects. What does it do when it hits that one? Also goes through it, goes up, connects. What does it do when it hits that one? Bounces off in a nice little curvy way. Right? And there you go. Starts up, ends up. Easy. Number 2, same exact scenario. Where are our intersects or our zeros this time?
-1/2.
-1/2 and 4. What is the degree of this polynomial? 4. So it starts up, ends up. So it starts up here. What's it do when it hits this one? Goes through it, comes around. Now, what's going to happen when it hits this one? It's going to like squiggle through. So I got to kind of prepare myself for that. So it looks like that. It has remember the cubing function shape, that squiggle? That's what it has at that zero, because it's a cube zero. Describe the end behavior using limits. Now, that is the only way we've ever described end behavior. The limit as x approaches infinity of the problem, and the limit as x approaches negative infinity of the problem. This is the end behavior. Now, before you start freaking out, this is easy. What is the degree of this polynomial? 3. Odd degree, starts down, ends up. But this one has a negative in front of it, so it starts up and ends down. So we don't know what kind of weirdness is going on in the middle, but it starts up and ends down, right? So as you go toward negative infinity, what's the limit here? Positive infinity. And as you go to positive infinity, it is negative infinity. All of these curves are either shooting up or down, right? And you're supposed to know which way. So your behavior is always going to be either negative infinity or positive infinity. All right, next. What's happening with this one? It's up and up. So that means on both sides we're positive infinity, right? Because it's up and up. The 4th degree polynomial is going to be up and just like this one right here. Up and up. You do not need to grasp these. You know by looking at it what the ends are doing. You may not know what's going on in the middle, but you know what the ends are doing. All right, from the zeros of the function. Well, wait a minute. Wait a minute. Don't you dare struggle with this. What kind of an equation is that?
Quadratic.
That's a quadratic. So you're not going to struggle with this. You're not doing PRRs. You're not doing Descartes' rule of signs. You're either going to factor it or use the quadratic formula. Complete the square, but that would be messy. Does this one factor? I think it does. But if it doesn't, we don't care. We'll just use the quadratic formula, right? It says find the zeros. The zeros are negative 1/3 and positive 2/3. This one's super simple too, because even though it's a cube, do not use the quadratic formula on a cube. Even though it's a cube, what do you notice about it? You can take out an x and turn it into a quadratic. Now, what does this mean, the fact that you can take out an X?
X equals zero.
One of your zeros is gonna be zero. Now, we'll either factor this quadratic, or we'll use the quadratic formula. Did I factor that right? So my other roots are -2/3 and 1. Absolutely. On just this part of the problem. All right. List all the possible rational roots. There's going to be a bunch of them. Here we go. Factors of 12. Over factors of 4. Now, when you build your list, remember, every one of these has to go over 1. Okay, that's easy. But every one of those has to go over 2. Now, some of them we've already got. 12 over 2, 6 over 2, 4 over 2. I'm going to have to add 3 over 2 and 1 over 2. Would you agree with that? And then they all got to go over 4. So 12 over 4, 6 over 4, 4 over 4, 3 over 4, 2 over 4, and 1 over 4. So there is my list. You can put plus or minus out in front. You don't have to list them individually. But those are the possible rational roots. So think about that problem we did in the homework. Think about in this one, if we figured out in this, and I'm making this up, but if we figured out in this problem that 2 was an upper bound, would that be helpful in this problem? Yeah, because wouldn't that knock out a bunch of options? So that upper bound thing and lower bound thing can be useful. Not in every problem, but it can be useful. All right, now what do we got? Find all the zeros and write the function in linear factorization. All right, let's just find the zeros and we'll worry about what that other stuff means. What do you want to do?
Possible rational.
PRRs, and this list is short. We've got factors of 4, right? Over factors of 1. 1 does work. Beautiful. And there's really good news, isn't there? What's left after we do that division?
What's number?
We have x cubed plus 4x squared plus x plus 4.
You can group that.
And that one actually groups. Now, if it didn't group, or if you didn't notice that it grouped, could you repeat the process? Could you try 1 again? Yeah, from this now, from your new reduced, we call this the depressed polynomial. You would try this one now and start finding numbers that work, but it does factor by grouping. So, I will just do that. So I need to make a list of my zeros. It said, find the zeros. So what have I got? What are my zeros going to be? 1. And 1, you guys guessed that one. And then we've got -4. And then we've got plus or minus I. Because if you solve this factor, don't you get the square root of negative 1? So you get I and negative I. Now, that makes perfectly good sense, because what's the degree of the polynomial? 4. How many answers should there be? 4. There they are. Now, linear factorization. This is a linear factorization. We write them as factors. So, what is the factor for 1?
X minus 1.
X minus 1. What is the factor for negative 4?
X minus
What is the factor for positive I?
X minus
And negative I. There's the linear factorization. Just write them as factors.
Could you write, x squared plus 1 instead of x minus 1?
That would not be a linear factor, that would be a quadratic factor. That would be like probably a normal way of writing it, but it doesn't follow the directions. Okay? Find a cubic function with the given zeros. Here we go. Write those linear factors, x plus 2 minus 3 plus 5. Okay, we're gonna FOIL this one out, so here we go. The order you do it doesn't matter. You have to multiply 2 of them, and then multiply the third one times that. So whichever order works for you. Did you guys get that? Now, when I don't have you to check me, like if I'm doing this, I'm trying to write a quiz or I'm trying to do my own work or whatever, and I don't have someone to bounce it off of, I can check this real easily. Because if I take 1, 4, negative 11, negative 30, and I divide it by negative 2, what should I get right here? A 0. And if I don't get a 0, then I messed up somewhere in my multiplication, right? And I have you to do it, I don't need to do that. Okay. Same problem. Now we're going to write one with complex zeros. So x equals negative 2 plus I, and x equals 4. Now, I told you something the other day. Did anybody remember? Were you listening? What do I know about complex roots, imaginary roots?
There has to be 2.
They have to come in pairs. And so you're never going to have just negative 2 plus I. You're also going to have negative 2 minus I. That's going to be part of it. So here we go. We're going to write our factors just like we did a minute ago. So what is going to be the factor for this minus 2 minus I? X plus 2 plus I. Move it all over on that side with the X. X plus 2 minus I. And minus 4. This time, I would definitely multiply these first. Because they're conjugates. It's all going to cancel. It's going to be wonderful. If it doesn't cancel, then you know you multiplied wrong. Now you are going to get an I squared. So you're going to have to remember that I squared is, well, that one's a negative I squared, so it's gonna be plus 1, plus 4, so I have x squared plus 4x plus 5. So my final answer hopefully is going to be did you get x cubed minus 11x minus 20 as your polynomial? All right, last one, divide. Okay, the first problem is pretty straightforward. What am I going to put in the box out here? Negative 5, and 3, 1, negative 4, 9, negative 3. I think I have all of my powers, 4, 3, 2, what have you. So this is easy, I'm just going to divide. Oh Lord, we're going to get big numbers. Mr. Lowell. Okay, I have no idea. Anybody else get that? Don't just blindly copy mine down because it could be so off. Anybody else get that? So, what's my answer? 3x to the third minus 14x squared plus 66x minus 321 plus 1602 over x plus 5? Vocabulary, this thing that we started with is called the dividend. This guy right here is called the quotient. That's the remainder, and this is the divisor. All right, last one. Now, this one is a little bit tricky because why? Yeah, so here's the deal, folks. If you're going to do synthetic division, long division, it doesn't matter. But if you're going to do synthetic division, you cannot have this 2 right here. So we're going to have to divide the whole shebang by 2. You can't just divide the divisor. You have to get rid of that 2, which you have to do in synthetic division. Everything has to get divided by 2. So in the box will go a 1/2. But now my dividend numbers are 2, negative 4, 1, and negative 1/2. Yes?
If you divide that by 2, or, wait,
So now 1/2 times 2 is 1. 1/2 times negative 3 is negative 3/2. 1/2 times negative 1/2 is negative 1/4, so negative 3/4. So now I'm left with this. Would you agree with that? Now, the answer then is 2x squared minus 3x minus 1/2 minus 3/4 over x minus 1/2.
Are we allowed to have the
No,
fraction?
you are not allowed ever in your whole life to have a complex fraction. That is not allowed. In any kind of situation ever in the world is that allowed. Okay? So what are we gonna do? This part's not bothering me. I'm perfectly okay with this part right here. I'm all right with that. But I gotta clean this up. So what can I do with this right here to clean it up?
Multiply by the conjugate?
Multiply everything by 4. So when I multiply everything by 4, the top will just be 3, and the bottom will be 4x minus 2. Now, if you don't like that, you could actually multiply everything by 2. And what would that change that? It would get rid of this fraction. And what would it change that denominator into? If you times this fraction by 2, wouldn't it change it into 2x minus 1?
Yeah.
And why is that kind of good news?
Because it's 2x minus 1.
That's what we started with, right? So if I did that, I'm going to get 4x squared minus 6x minus 1 minus 3 over 2x minus 1. Now, either one of these are fine, but that one looks better because it's giving you the original divisor back again for your root. All right, go ahead. And grab your 50, and in your seats at 50. In your seats at 50.
Yeah, I want to know. Don't worry, we'll.
In your seats at 50. Have a good lunch.
That's not a good day.
Have a good lunch.
Oh my god.
The quiz that I'm giving tomorrow, well, do you feel like you're ready to take the quiz tomorrow? Ready all that stuff? Okay, I don't care. You just gotta get all this stuff made up.
Yes.
So the longer you put it off, I mean, the more you put off, the more you put off. So just don't put it off.
We'll put it up.
Yep.
I will do all the homework for practice.